Okay, this is, let's finish up worksheet 4, fall exam review worksheet 4. This is number 5. Okay, given that a function is continuous on the closed interval from 1 to 5, and that f takes the value shown in the table, the function will have two zeros, or in other words, two x-intercepts in the interval between 1 and 5 if. So it helps, so we're trying to figure out for what value of k can we guarantee that the graph will cross the x-axis twice, okay, or we'll have two zeros. We already know the function is continuous. We know there's not going to be any breaks in the graph. So it helps if we sketch the graph out and kind of visualize what's happening, and also visually convince ourselves with the answer. So my first order pair is 1, 4. My second order pair that I know of is 5, 3. So the only k value at 3, I need my k value, or my other y value, to be below the x-axis, right? If it's on the x-axis, I can't guarantee that the graph will cross the x-axis twice. If it's 1, 2, or 3, it's possible, but where the graph may cross the x-axis elsewhere. But in order for us to guarantee that the graph crosses the x-axis twice, we need the y value to be below the x-axis. And because of the intermediate value theorem, we know it's going to cross through every point between -1 and the highest point, 4. So we can tell also that the graph will obviously cross the x-axis twice. Okay, number 6. I know that this didn't quite show up very well on the review sheet, but this should be the second derivative. Okay, so the second derivative is given by x times x minus 2, x plus 1 squared. Then the graph has points of inflection when x equals. So there's already a second derivative. We can just find the critical points by setting each portion equal to 0. So we get critical points at 0, 2, and at -1. Okay, so we put those critical points on the sign line, plug -2, and we're going to get a positive value. This is always a positive value, so we're only going to be testing these two regions, so negative and negative. Plug in -0.5, you're also going to get a positive value. Plug in 1, you'll get 1 times 1 minus 2, which is negative. If you plug in any value greater than 2, you'll get a positive and a positive. Okay. So there's no change in signs at -1, so critical points, even though there's 3 critical points, only 0 and 2 will be points of inflection because there are change in signs there. Okay, number 7. We have a piecewise function, and we want to find out what is the limit as x approaches 1. So let's find the limit as x approaches 1 for both of these branches and see if they're going to agree. So the limit as x approaches 1 from the left side of 1 will be x cubed e to the x. The limit as x approaches 1 from the right side of 1 will be e to the x over x cubed. So if we're evaluating one-side limits, the first thing we always do is we just go ahead and plug in that x value. Only when we get something that is undefined, then we have to consider where the one-side limit may be positive or infinity. But the first thing we always try is we just plug in that x value. So if I plug in the 1 in for x, I'll get 1 cubed times e to the 1, which is just e. If I plug 1 in for x, for the second piecewise function, I'm going to get e over 1, which is e. So I know my limit will exist at e because the one-side limits are going to agree. Okay, number 8, we want to find out the derivative, dy over dx. Notice if you look at your equation, you have x and y's mixed in together, so we got to go through product rule because of x and y, because of two separate functions, but also we have to go through implicit differentiation. Okay? This function is not explicitly defined for y. We have x and y mixed in together. Okay. So now we find the derivative. 3x squared becomes 6x. 4xy, you have to go through product rule. So f prime g plus f g prime. When we get to g prime, y becomes dy dx. Don't forget, you also got to find the derivative for 1, which is 0. Okay, so a lot of students forget this step of taking the derivative of a constant. Okay, we're solving for, we just want to find out when x is equal to 1. So we want to find the derivative when x is equal to 1. So even though we can replace 1 in for x, we're missing the y value. Okay, so we need to find the y value, and so that we can do, we can find by plugging 1 into the original equation. So here, down here, we can find the y value by plugging 1 in for x into the original equation. So if I plug 1 in for x, I'll get 3 times 1 squared minus 4, 1 times y equals 1. 3 minus 4y equals 1. Negative 4y equals negative 2, so therefore y is 1/2. So I need to take that extra step of finding the y value because it's not given in the problem, so that extra step is required. Okay. Once I have the y value, I can plug in. So 6 minus 4 divided by 2 is 2, so 6 minus 2 minus 4 dy dx equals 0. Combine like terms, subtract 4 from both sides. So dy dx is equal to negative 4 over negative 4, which is positive 1. Okay, we have a function given by f of x on which of the following intervals is f decreasing. So we can simply find the derivative, critical points, sign line, and then test each interval. So find the derivative going through power rule, factor out 2x, set 2x equal to 0, set 4x squared minus 3 equals 0. So we have 3 critical points, one at 0, and the other 2 with the plus or minus root 3 over 2. Okay, so we put all that on the sign line, test each interval with the derivative. We get negative, positive, negative, positive. So our function will be decreasing in these two intervals from negative infinity to negative root 3 over 2, and then also from 0 to root 3 over 2. Okay, so answer choice will be E. Okay, number 10, if our function is continuous on the closed interval and differentiable on the open interval, which of the following must be true? Okay, so if you look at this, continuous and differentiable on the closed and open interval, we know that these are already the first two conditions for Rolle's theorem and mean value theorem. So if f of a equals f of b, then for some value between a and b, f prime c is equal to 0. So this just spells out the rest of Rolle's theorem. So we know that's going to be true. Right? If k is any number between f of a and f of b, then there's a value such that f of c is equal to k. So this is spelling out intermediate value theorem, and we know this will be true because it passes the condition for continuity. There's a value c between a and b such that f prime c is equal to f of b minus f of a, all of b minus a. So this is mean value theorem. Now Rolle's theorem, mean value theorem, they both share the same condition, continuity and differentiability. Intermediate value theorem only needs continuity, so it has that, so all three conditions will be met, so answer choice will be E.